Hello, and welcome to today's lesson on the classification of waves into transverse and longitudinal types. Our plan for this lesson is as follows. We will begin by introducing longitudinal waves. We will then introduce transverse waves and finish by comparing and contrasting the two different types of waves. So far, we have explored what is meant by a wave. You are familiar with the basic concept that waves are disturbances that transfer energy from one place to another. Building on this foundation, we will now dive deeper into specific types of waves, transverse and longitudinal waves. Understanding these classifications will enhance our broader comprehension of wave behaviour. Let's get started. In a longitudinal wave, the particles of the medium move back and forth in a direction parallel to the direction in which the wave travels. This means that the particle displacement is in the same direction as the wave propagation. To visualize this, think of a slinky stretched out on a table. When you push and pull one end of the slinky, you create waves that travel along its length. As you observe, you'll notice areas where the coils are close together, known as compressions, and areas where the coils are further apart, known as rarefactions. These compressions and rarefactions travel along the length of the slinky, demonstrating how the particles move back and forth in alignment with the direction of the wave. Sound waves are a practical example of longitudinal waves. When you speak, your vocal cords vibrate and cause air particles to compress and rarefy. These compressions and rarefactions then travel through the air to reach your listener's ear, enabling them to hear your voice. The movement of these particles is parallel to the direction of sound wave travel. In contrast to longitudinal waves, the particles of the medium in a transverse wave move perpendicular, at a right angle, to the direction in which the wave travels. This means that the particle displacement is at a right angle to the wave propagation. Imagine holding one end of a spring and moving it up and down. Waves will travel along the spring, but the particles of the spring move up and down, perpendicular to the horizontal direction in which the wave travels. This perpendicular up and down particle motion typifies a transverse wave. Water waves are a practical example of transverse waves. When you drop a stone into a pond, the energy from the impact causes the water particles to move up and down. The wave moves outward in ripples across the pond, but the water particles themselves simply oscillate vertically. This up and down motion while the wave travels horizontally is characteristic of transverse waves, where the particle movement is perpendicular to the wave's direction of travel. Visible light is a transverse wave. The physics behind this becomes quite complicated. In fact, a full exploration of it leads to quantum mechanics. But light consists of an electric and magnetic field oscillating perpendicular to the direction of the overall wave motion. We will examine light and its properties in further detail when we come to electromagnetic waves. Let us now summarize the difference between longitudinal and transverse waves. In longitudinal waves, particles move parallel to the direction of the wave. An example is sound waves. Comparatively, in transverse waves, particles move perpendicular to the wave's direction of travel. Examples include light and water waves. In general, both longitudinal and transverse waves require a medium to travel through. The exception is electromagnetic waves, which are transverse. These can travel through a vacuum as well as through any medium. In today's lesson, we explored the distinction between transverse and longitudinal waves. We learned that longitudinal waves involve particle movement parallel to the wave's direction of travel, with examples like sound waves. In contrast, transverse waves feature particle movement perpendicular to the wave's direction, such as water waves and light. Recognizing wave behavior helps us understand how energy moves through different media, laying the groundwork for advancements in fields like communication, medicine, and engineering. Watch the rest of the GCSE physics course at Sophos Education.